So hi, Yaroslav. I think I know you pretty long time, and you are one of the founders of NetBeans, right?
Oh yeah, but that was a long time ago.
When was it? 1997?
Right, so it's more than 20 years.
What I'm curious, how it started. So I mean, where you got the idea? Was it by a beer or in a pub, or what was the ignition?
Yeah, it started at Charles University when we got into fourth or fifth grade. We were asked to have a software project, some collaborative work of 3 or more students. So we were sitting, like 80 students were sitting in a room and listening to presentations by various teachers offering to control a robot or build a database for a hospital. And we were, me and few my friends, sort of annoyed by that, and we wanted to do something different. So after the presentation we met and we said, okay, we want to do Delphi for Unix, for X Windows. So we sort of liked the idea and then walk around the university to find a professor who would like to lead us. And then we found Adam Dingle, and Adam Dingle was visiting professor from United States in Prague, and he didn't know what it means to lead 7 students on a software project, so he agreed, and we started to work on that. So Xelphi was born at that time.
Okay, and Xelphi was meant to be implemented in Java from the beginning, or?
No, not at all. It was supposed to be implemented in C++. But the problem was that for the first 6 months, maybe even a year, we were meeting and discussing the general design, the great ideas how we will do it in C++, searching for the perfect framework. At that time, Qt was not there. GTK was not there either, so we were basically we selected something called WX Windows, which was a portable toolkit of 20 years ago, but it was so painful to get started, so I proposed to use Java, which I gained some experience on other project meanwhile with Java, and I proposed to use that, and everybody was smiling, saying no. And so we were meeting for next few months, and at the end, after 3 months, I proposed it again, and we decided to do it in Java, which was a relatively clever decision.
Now the question is, how did you found Java? So what was your the first contact with Java?
So I was curious about languages. There was a presentation, something like all the obscure languages of the world, where we learned something about PL1, something about Lisp, APL, so all the forgotten languages of the past. And in addition to that, there was also a course about the new fancy language called Java. So I subscribed to it, and I needed to do some homework as well. So that's how I got connected to Java.
Ah, cool. And okay, then it was accepted that NetBeans or Xelphi is supposed to be written in Java. And have you changed the name immediately to NetBeans, or you just...
No. We kept the name Xelphi, like Delphi for X Windows, for the whole time of the student project. And actually we finished the project, and it was relatively successful, with successful result. Because at that time, basically, nobody at the university was able to run Java program. So, so of course, when we did the presentation, we knew what parts work and which parts we should avoid. So the presentation was fantastic. And nobody from the professors could try the program themselves because, not having enough interest and knowledge of Java. And also we had enormous amount of documentation because Java came with the invention of Javadoc. So we could actually generate a lot of documentation from our code without actually documenting anything, which was impressive as well. So we got good marks. But actually the Selfie project the program was working, so we decided to sell it as a shareware. And we continued for up until the end of year 1998, I guess, or seven. And the result of that is that we were contacted by Roman Staněk, the entrepreneur who was seeking for some investment opportunity, and he needed some developers. And together, then we formed a company that later became NetBeans.
Okay, so that's interesting. Okay. So, by the way, 2 weeks ago, I reviewed a project, and the all getters, setters, and constructors were surprisingly well documented with Javadoc. So, I mean, this best practice still holds after 20 years. Generate a lot of Javadoc, meaningless stuff, but clients are very satisfied because we had, all public methods were very well documented. There was.
That was not our case. We just generated documentation, so there was at least a list of the methods, which pretended to be a documentation.
Yeah, I mean, what's interesting is how well the old JDK methods are actually, how well they are documented, right? So if you look at JDK or Java or whatever came from Sun or now from Oracle, so the Javadoc is actually very good. And if you compare it with commercial project, it's really poor, because what the developers are doing, they are just rephrasing, the method signatures usually, or what the IDEs are doing. And that's interesting. So what interests me, how long did it took to have something usable? So there was 8 people, what I understood, and you create the IDE. So how long did it take to create an IDE in Java?
So first of all, we needed the 1 year of going into pub without doing anything. And then it was written in something like 4 months. And we got something relatively usable. Then the next few months to polish it. So I do say 8 months to get the student project running. But then when we founded the company, with Roman Staněk, we threw most of the code, almost all code away, and started from scratch. It's like the approach for version 2.0. And then once again, we throw it away and started version 3.0.
So one question. What you did in the pub 1 year, was the time useful?
No. Well, of course it was, but not for the project.
Yeah. This is back then. You probably draw some diagrams or whatever, right?
Or at least describe the visions over the beer.
Yeah. Okay. Very good. Because I think right now what I would do, I would just start, right? Create a prototype, throw it away, rethink, and just starting and thinking at the same time, right?
The problem was that we would start in a wrong language, so that would not work at all. Well, if your language is set, then of course, yes, you can start with prototypes. But
you're right.
If you are completely in flux, it's probably better to just talk.
Okay. And who is Roman Staněk?
So you don't know?
No.
Really?
No.
Yeah. So he was a director of Sybase, which is a database company for Middle Europe at that time, and he was sort of bored with that job, so he wanted to establish a startup in Prague or in Czech Republic, and he did it. He managed to sell NetBeans to Sun Microsystems. Then he left and he founded another startup called Systinet, which was about web services, UDDI, enterprise orchestration, all the important stuff that is SOAP, which is dead these days. And he managed to sell it to HP. And since then, he created a business intelligence company called Good Data. So right now, he's still working in Good Data. And it's probably his longest running startup.
Still Java right now?
No. As far as I know, they are polyglot.
Yeah, of course.
So, certain things are written in Java, some things are written in different languages, Python. They also even use Ericsson is using the functional language.
This is Erlang.
Erlang, yeah, they also tried Erlang. So they are really polyglot, which is so easy with Docker images and all the cloud infrastructure and microservices. You can be very polyglot if you want.
If you want, yeah. Okay, so we have the third version of NetBeans. So you started over, and the company name is now NetBeans, and the product is NetBeans, right?
Well, the company... Are you talking about the time 18 years ago?
Yes,
so,
that's what the Roman Staniak founded the company, NetBeans. Was your idea to name it NetBeans, or whom idea was it?
Yes, it was my idea, of course.
Oh, very good. Yeah, really? Nice.
So when we were about to found the company, we were investigating different approaches, and one of them was to build upon the student project to continue building an IDE. The other option was to just fit into an existing IDE. Do you remember the IDEs of that time?
Sun Java Workshop,
yes,
Sun Java Studio, Semantic Visual Cafe.
Oh, then, perfect, that's it. PowerJ. PowerJ. That was
PowerJ?
Yes, that was done by Sybase, and also JBuilder by Borland.
JBuilder?
Yeah.
And I wanted to try because of the name. It was called Code Warrior.
Code Warrior, yes, that was there as well, right? Yes.
The coolest name ever, Code Warrior.
Naming is the important.
Yeah. The NetBeans also nice. Okay.
So we were basically investigating the option whether we could somehow describe the topology of a network and fit into those IDEs, into the existing IDEs. And how can you fit into existing IDE? Well, there was the specification called Java Beans. So you would need to create Java Beans describing the topology of the network. So I wrote down the proposal, or basically a paper describing how that could be done, and I needed a name, and of course, it would be Java Beans for network, so I call it NetBeans, and they were supposed to be the pluggable components into any IDE. Later, we just give up on that effort because extending the Java Beans could work for simple stuff, but not for something as complicated as we wanted.
But have you got the prototype running on? You remember the Beanbox?
No,
the Beanbox. It was it came from with the JDK, so you can run Visual Java Beans inside a Sandbox, and I think the name was Beanbox, Java Beanbox. So you can run it. It was like a very small, not IDE. It was like just a window, and you can just open Java Beans within the Beanbox. It was JDK 1.1.
Yes, I think I do have some memories of something like that. The problem is that if you want to describe the topology of network, you need connections between the beans. And the Java Bean 1.1 specification was not good enough for that. There was a proposal for enhancing the Java Bean specification called Glasgow Java Beans. And
was it Infobus?
It was not Infobus. It was the Bean context.
Okay.
And it actually got somehow integrated into JDK 1.2, but it was so complicated that no IDE actually implemented that. So again, that would not work for the integration at all. But so at the end we basically decided to build the IDE, and actually I created an abstraction over the Bean context Java Beans, which is called NetBeans Nodes API. So the Nodes API was basically the abstraction for connecting Java Beans into a tree-like structures. And that was basically the base of NetBeans, the IDE. But originally, let's go back to the name. Roman Staniak was in favor of using a name called Lime Tree for the product. So the IDE was supposed to be called Lime Tree. And there was a competition, internal vote, when everybody could suggest a name, and there was a voting. and every guy had one vote except Roman Staněk as a founder with majority. He had 30 votes. So at the time, his proposal Line 3 won because we were just 15 at that time. But it turned out that there are some trademark issues with that name, and so we were searching for a different name. And then somebody realized, okay, what about the NetBeans name? That was not that bad. And basically, NetBeans was selected completely by an accident. But
Very good.
But I'm the inventor of the name.
So there was a 30 against 15, right, in the vote? So 15 engineers versus one founder, right?
Well, maybe it was something like 37 against 7, but the case was decided before it even started, of course.
And could you buy something already, or you just developed? So could you buy the version 3 of NetBeans, or what was the business plan?
We were actually selling the version 2.0.
Okay.
You could download it for evaluation period, and you could buy it. The biggest success was with the version called X2, NetBeans X2, which was an enhanced version of NetBeans running on JDK2. Because at that time there was a nasty thing with the renaming of the Swing packages. Originally, Swing came out with Sun, Swing,
exactly.
And then it was renamed to Java X Swing. And NetBeans was the first IDE that supported this change and was running fine with JDK2. So people were actually buying a lot of licenses for this NetBeans X2 version, and that probably attracted Sun Microsystems, so they were willing to buy.
How much was it? You know it? You remember? How expensive was it?
$60 or something.
Oh, $60. Or for that time, there was nothing. I remember all IDEs were pretty. There was like standard, professional, and enterprise. And the enterprise was always, several thousand euros because they had database connectivity and whatever. Professional, I don't know what they had, and standard was just basic IDE.
I think we had some different and editions as well. I don't remember the pricing, and I think people were mostly interested in Swing anyway, which was in the basic version. And
I think around 1999, I also looked at NetBeans. What I didn't like is, and this is why I didn't use it for longer time, I tried to add some jars, and the problem was there was no class path. As I remember, I had to mount them.
Yes.
And I say, what the hell is mounting? They are just crazy. I mean, I would just like to standard class path, and this was just mount. And the concept was nice, but I didn't like the idea that this is not like plain Java rather than something very specific. And this was the problem. My problem was the early NetBeans days. But did it change completely later?
Because Java changed. I think in the early days of Java, you actually would do some form of mounting. The people like the project that people would develop in the early days was really just a set of class path roots, and that was it. So NetBeans philosophy was derived from that. But later the projects became more complicated. People started to use JSPs or servlets, and those actually require different approaches than just like a flat class path of classes. So we struggled with that for a while, but then we came out with a project system that is in NetBeans up until today.
Okay, so and then the NetBeans company was, so you got the attention from Sun with X2 version of NetBeans, and how you got the attention? You got email from Scott McNeely, or what happened?
Well, that was the hard work of Roman Staněk and few American-speaking employees. The thing is that I remember Roman saying once that he managed to sell the company to Sun Microsystems, and that was the best or the most that was possible over phone, because we had no subsidiary in Silicon Valley. We were basically operating over the phone from Prague, and that was definitely challenging. So for the other companies like Systinet and Good Data, they all have the headquarters in San Francisco area, because then, well, you know, you go in Silicon Valley, you shake a tree, and a venture capitalist falls down on a pavement, and you can talk to him. While in Prague, you shake a tree, and there are no venture capitalists who would fall
Just
down.
beer falls down, right? In Prague.
Yeah.
Okay, and this was, and then it was sold. And what happened then? I mean, so there was some discussion with Scott or with James, or you remember that?
The guy who actually bought us was Jonathan Schwartz.
Ah, okay.
So that's good, because he later became the CEO of Sun Microsystems.
Yeah, exactly.
So that's good, because having a CEO who can spell NetBeans is better than a CEO who does not even know what it is. So that was.
Which role had Jonathan back then? Remember that?
He got a lot of money to support independent out of Sun development or support of Java. So that's exactly what he was doing. He spent some money on NetBeans.
Yeah, Jonathan really liked NetBeans back then. I remember he always supported NetBeans.
That's true, yes.
Yeah. Okay, so you sold it to Jonathan, and then it became open source, I guess, right?
That was sort of surprising, but so we got acquired at the end of 1999, and in 5 months, it was Sun decided that we will go open source.
Okay.
So we did, and that was of course a great thing to be. Since then, I don't want to develop closed source software at all. I'd like to develop just open source, if possible, because it's so much like with in-house software, you are at mercy of the business decisions, and if you code something, it can be lost forever, because it never will be seen from outside of the world.
Yes.
With open source, everything you do is going to be seen. Whether that gets into the product or not, that's a different question, but at least it's not completely lost. So I like open source very much.
And in addition to that, it is a little bit insurance for client. If I do something for my client and it's not business critical, I always ask them, we can do it in open fashion, because if I disappear, someone else could lend us, and take over, because a lot easier. But if I do something closed source for my clients and I go away, the chances are very low that someone can pick up and proceed with the project. So this could be also good for the business for my clients. Question regarding the NetBeans.
Yes, that is correct.
When it happened with Jonathan, was it 1999, 2000?
1999. The deal was done on 20th October of 1999.
Oh, this is really early. So
it took just 2 years. So it went fast. But the thing is, well, actually, Sun Microsystems had the JDK, but Sun was incapable to create IDE. So there was the Sun Studio, Sun Workshop.
And Studio, yes. I still have the CDs.
And it was not really usable. So actually, well, when they had the option to buy a company from Czech Republic, which was cheap, that could give them 100,000 of subscribed users for almost nothing, why not do it? And so for them, it was just like no-brainer. So Sun paid the money and acquired us, and probably was expecting that NetBeans will end up as any other acquisition by Sun Microsystems. I mean, like completely vanish in few months. And I think we were the longest surviving acquisition Sun ever did. So
And Hotspot as well, right? Hotspot from JVM is also was the Sun acquired, I think, the company from Smalltalk, and this is the Hotspot JVM right now. So I don't remember.
I don't know anything about the company doing about a company doing Smalltalk and being acquired. I know that Sun Labs were investing heavily in self language, and that the team working on the self language was basically optimizing
like this.
Optimizing Hotspot. But that's not an acquisition. That was just
you're
internal
right,
transfer from laboratories to product.
Okay. Question what I had is, have you... what was the package structure? Was COM NetBeans, and you had to rename it to something org NetBeans, right? During the open source phase, or was it just rightly named back then? Do you remember that?
Yes, I do. So originally, this is something that got me into the API design business, because common advice is code against interfaces, not the implementation. And when we tried that, we actually realized that we are fully mixing implementation and interfaces, and there is no clear separation of what should be public and usable by other parties and what is internal implementation detail. So, and this happened in 1998. And in a response to that, what we did is we repackaged the classes that we were considering API into org open IDE package namespace.
Ah, perfect.
And it's still part of NetBeans. So
yes, it still is.
Yes.
But this is, I think, is based on your abstraction from Glasgow, right?
There is org openid.nodes package, and that's the abstraction of the Glasgow Java Beans.
So from the early days, the NetBeans was separated in the API and SPI.
Before we got acquired by Sun Microsystems, yes, we already knew what to do.
Then it was a perfect acquisition, actually, for Sun, right? For Sun, because they got something which could be already open sourced. Usually, if you try to open source internal project, there's lots of junk which has to be refactored. In your case, it was clearly structured.
Of course, it was completely clearly structured.
No, clear structured, but at least you had.
I think that Jesse Glick, who was doing a lot of work on the open sourcing, had to clean up a lot of things anyway. So. It was
Jesse. I know him from mailing lists. He did lots of test harness and stuff like that, right?
Yeah. And he even did the new project. So his contributions are clearly visible in NetBeans.
Okay, so I looked at your LinkedIn profile. So this was your first time. So you were the NetBeans engineer, and then you are the NetBeans platform architect. And this is just because the company changed, right? Or was it a different role? So you became then NetBeans platform engineer, I think, right?
I would not differentiate that. So I was one of the founders, and since then I was basically designing the architecture. And that continued and probably continues up until now. But I basically so the thing is that I actually don't care about the IDE much. I care about the platform, and over time the IDE grow to bigger, to be too big to be designed by one person. So we needed to learn how to design or how to apply the best API design practices in a team. And I focused mostly on the NetBeans platform.
Are you still involved with the Apache open sourcing NetBeans process right now, or not?
Yes, I contribute there. Because actually certain tools in Oracle Labs organization where I'm working right now are built on top of NetBeans platform. So we need to make sure that whatever we need is part of the Apache NetBeans.
Hey, cool. So this is good to know, because so then someone from Oracle is also working on the open source version of Apache NetBeans. But you actually changed to Oracle Labs, right?
Yes, I did. Well,
2014
after 15 or more years on a single project, it's probably time to change.
Yeah, you are excused, so 15 years are okay. And you started with something interesting, but before you started with Graal, you probably also know Tony Apple, right?
Mm-hmm, indeed.
And he did the Duke script thing, and you were also involved, right? A bit.
Yes, yes.
Do you help him a little bit? But what you did is actually the Java in a browser. Back then, right?
Yes. That's.
And what was it? You know what did it? That thing.
Somehow in. Yeah, okay. So let's start with the Oracle acquisition. So when Sun was acquired by Oracle, we were sort of afraid that NetBeans is going to be in tough position because Oracle had their own IDE, JDeveloper. So I was focusing on solving this situation. And my proposal was to make sure JDeveloper switches to OSGI, NetBeans can support OSGI, and if that is what we have, we can use OSGI as a common ground for exchange, for somehow mixing and combining NetBeans with JDeveloper. So this is what I was doing up until 2012, when we actually managed to successfully move this project forward. So right now, if you download JDeveloper, it's basically built on top of NetBeans platform. Windowing system, form editor, profiler, module system, all is coming from NetBeans. So it's so easy to share. So that I was satisfied with that, and I thought in 2012 that I need a new challenge.
Yes.
And I said, okay, maybe the biggest problem for Java is that it's not moving forward as much as the JavaScript space. And I'd like to do something with that because Java is good ecosystem, good language, and I would like to bridge the gap between JavaScript and Java. Based on that, I was basically trying to find out how you could use the HTML technologies and still write in Java. And I don't mean server-side Java. I mean client-side Java, when you basically can manipulate with the DOM, modify HTML, modify CSS, and use Java as a full-featured language for the client-side development, and even make it run in a browser, in spite of browsers trying to avoid running Java at all. So that was basically the starting position in 2012.
And it worked. So I took a look at that, and what it did. So what is it? It looks like the Java Lang API running in browser, right? This was my impression. It's
so wild. The whole idea is to be able to somehow connect the renderer, which is either a browser or HTML rendering component like WebView, with a Java virtual machine. And depending on the type of platform that you target, you can have different renderer and different virtual machine. So if you run on Android, what's the best virtual machine there?
Yeah, Dalvik, probably.
Indeed. So, this is basically, or I started with those ideas, but as you mentioned, Tony Apple moved or finished them. So, as part of his Duke script project. So basically, the idea with the Duke script thing is that you just select the best Java virtual machine and best renderer. So for the Android, you select Dalvik as the Java virtual machine, and you use the WebView component that comes with Android UI. If you run on iOS, then what's the best UI there? It's WebView from UI WebView component from Apple. And do you know Java virtual machine that would run on iOS?
Probably something 68,000 port, right? Something like this.
Oh, there was some attempt from Oracle to do
ARM.
to do the ARM virtual machine, but the problem there is it was just an interpreter, so that one was slow. But
then RoboVM.
There is RoboVM, which is an open source project that can translate ahead of time Java into ahead of time binary. And that's fantastic. And also recently there is something called multi-OS engine from Intel that can do the same thing. Again, ahead of time compilation of Java into ARM iOS ready binary. So again, you just bind these two and you can run. So and the same thing applies to desktop. On desktop you can use the regular hotspot JVM. And you connect it to some renderer. My work was using JavaFX WebView integration, but Tony also offers native WebKit or some JAX browser components that render more effectively. They are better browser components. And one thing that I also did was ability to take the Java and transpile it into JavaScript. And then you can actually run the same application directly in a browser. So
this is what I meant. This is this cool stuff I saw in the browser. This is back to browser, I think, right?
Yes.
Back to and browser. And this was a transpiler. So you wrote a transpiler, which
I could do ahead of time or even just in time transpilation of Java bytecode to do JavaScript. So you could basically took your jar files, convert them into JavaScript and load them in a browser, and that works.
So this is cool stuff. So this is truly next challenge after NetBeans platform. But
what I have found it out is that in spite of being able to run Java everywhere with this stuff, people don't care because if you are Java developer, then you are most likely a backend developer, and you don't want to know anything about the front end. So you tell your junior colleagues to write the front end, and junior colleagues are not afraid of JavaScript, so they will switch to JavaScript. And if you are a junior guy and you are asked to run something on a server, you are not going to do Java anyway because you know JavaScript. So you will use Node.js on the JavaScript. So basically the whole effort of like Java running everywhere in a browser, it's too late. It looks like Java is the new COBOL. Nobody is going to use Java for new projects. So that's another reason why I think the work that we are doing in Oracle Labs is probably a better direction for at least saving the Java virtual machine.
The problem what I also see is the new JavaScript versions. They're looking more and more like Java. So and actually easily switch between Java and JavaScript, and you can build almost identical code. Even the lambdas. There's a little bit, some syntactic differences, but it is very, very easy to learn right now. What I really didn't like is the earlier versions of JavaScript with the vars and functions and modules, and this was I didn't like at all. But right now with the ES6 modules and we have almost classes and the API become more robust. It's just nice language, I have to admit. So,
are you coding in this version of JavaScript, or are you using also TypeScript?
I'm using when I'm coding in plain JavaScript, and if I'm coding with my clients, what I advise to do this, I also advise to use first plain JavaScript, and then they can decide whether they should add TypeScript or not. I would not start with TypeScript, and the reason for that is, as first, if you probably know me, is unnecessary dependency. And the problem is, if you show Java developers TypeScript, you get the same crazy stuff what you get in Java, dynamic proxies, factories, interfaces, what you probably don't need in a small web app. So what you do is try to keep it simple with ES6, and I even try, to not to transpile with Babel. Just if we know the browsers in an enterprise, you can do this. You say, okay, we just target Chrome. So keep it simple, no transpilation, and then this is crazy fast and there are no dependencies. My clients are happy because there are no migrations. So this is my way to do. But if they say we cannot, it never happened. But if they could say, we have problems with refactoring or whatever, then I say, okay, then we try TypeScript or React Flow or whatever. But I do not start with that because it's exactly what I did in backend as well with Java EE. No dependencies, stay with the core, and there are no migrations. And larger companies really hate to migrate something without a reason. And if we would do TypeScript, Elm, or whatever right now, the chances are very high that we will have to migrate in the next few months or few years, 2 years, and no one liked that.
Where do you want to migrate?
No, yeah, with a framework, Angular 1 to Angular 2, for instance, right?
Oh, that's not TypeScript.
No, but TypeScript,
Angular is a fantastic example of killing your own framework by trying to produce version 2.0, which is incompatible.
No, but TypeScript is more like you are extremely dependent on the language if you do it more, and you can only hope that part of the TypeScript become part of the platform. They work very closely, but I mean, the added value is small if you start small, and then you can decide whether you can use TypeScript or not. It's not like, we have to decide up front, because you can always add TypeScript afterwards.
Have you noticed some increase in the amount of tests that you need to write? Because I would expect a dynamic language like JavaScript needs probably more tests than a typed language.
Yeah, what I have to admit, we don't have a lot of unit tests. Although it is fashionable, we don't have a lot of business logic in the client. So what we have, presentation logic, some offline logic, and what we do, we use end-to-end tests more. So we test more. I try to invest more in end-to-end tests from the beginning, to automate the full UI.
That means Selenium and WebDrivers like this. So clicking in a browser.
Yeah, exactly. Not Selenium is a little painful to use. We use Cypress, for instance, an open source tool is easier to use than Selenium, and is also headless. We use this, and you can start with Chrome or outside Chrome, and we invest in this first. And sometimes, if we have crazy business logic, then we write straight Mocha tests or something like this. So just keep it simple. But this works well. So we had, I did 40% of my time, I would say, JavaScript native right now. And the same mindset as Java EE, and the developers really like it. So new JavaScript developers know what to learn. I show them MDN and that's it, web APIs. And the Java developers really appreciate that the JavaScript looks like Java. But this is a side.
And does it mean that basically those developers also consider using the same language on the server side?
Never. I get asked about Node.js a lot of time, but I have to admit, in all my project, everyone is really amazed still with the productivity of Java EE. And right now with microprofile and Jakarta EE, it is the demand is like crazy. So
what about the logic that needs to be shared between the client and server?
We don't have a lot of that. Back in some projects, we had bin validation or something like this, which could be. So we use NAS1 for that, for instance. You could use it like this. But the truth is, this is not a common use case to have shared code between client and server.
Well,
so right now in my project.
What about validation? So basically, you need
bin validation. What I meant, bin validation, and this really depends on the project. If you have, for instance. This is not exactly a thin client, but GSF is able to do this, Prime Faces, the new version. And if we have a plain framework, I mean, what you can do, you can use NAS1 and use the Java code, JavaScript code on the client side and validate your stuff. And on the server, what you can do, you can load the JavaScript as an interface and use the interface, internally, and the performance is good enough. But back to you. We should do another episode. What I would like to do, we should talk really deep about this topic and API topic. But right now, I'm more interested about Graal. So you are running in Oracle Labs. You are working on Graal since the beginning, right? Of 2014 or something?
Well, it's the beginning of the Prague office. But Graal itself started in Linz, in Austria, and that was way sooner than I joined.
Okay.
So I remember that in 2005, I was invited into Linz Johannes Kepler University to give a talk about NetBeans platform, because there was a cooperation of that university with Sun Labs on Hotspot. And basically one of the things that we're doing, they were visualizing like graphs, the compiler decisions for optimizing the Java code. And that tool is called IGV, Ideal Graph Visualizer, which is actually one of the tools built on top of NetBeans platform still in use.
Because before we start with that, one question to you. Do you know the project Maxwell and Sun Labs?
Maxine, I assume.
No, Maxwell. Like Maxwell, where it was in 2007, we had a chat with James Gosling, and what they tried to do is to write JVM in Java.
It's called Maxine.
Maxime.
Maxine. It's a Maxine virtual machine. Yes, I know it, and actually it's based for what we do right now.
Cool.
In order, well, Maxine was great for the research, but in order to productize it, we need to take a step-by-step approach. We cannot just rewrite the whole hotspot at once, because it's then hard to get into production. So the approach that we have is now split into Graal compiler, which is replacing just a C2 compiler with a different compiler written in Java.
One question. So the end goal is to have Java written in Java. JVM written in Java, right? Is this the end goal of Graal?
Well, that's not the goal. That's the solution for a problem that Java has currently.
Okay.
Because if you look at the innovation in the compiler space of Java, what do you remember any innovation in last 10 years?
Innovation
in the compiler. And I don't mean Java C, I mean the bytecode compiler into the assembly.
No, it's just lambdas, right? This is the invoke dynamic, I think, was the last.
That's not in the compiler either, because it's generating lambdas are basically generating the proxy classes behind the scene with ASM when you first use the lambda. So then it's just the old C2 compiler as we were using it in 2006. So the compiler is basically 11 years old, and nobody touched it significantly or improved it significantly since then. And it's still a great compiler, which means Cliff Click did good job when writing it, but we think we can do better. And one of the reasons why people are afraid to touch the compiler is that it's written in C++. So in order to work with the compiler, you need to learn C++. You need to learn completely new build system. You don't know how to debug it.
Which build system is it?
Of course, it's Make. But, but do you know how to debug? I mean, how to debug the hotspot C2 compiler. I don't know. You need to launch the JVM in some fancy mode with switches that I don't even understand. and then you need your IDE to understand the source structure of C2 compiler. Actually, NetBeans do understand it, because the C&D team working on support for C actually created perfect support for that. But it's still painful. And as a result of that, the C2 compiler is not moving forward. And which, for example, shows in the way Nashorn works. Nashorn is far slower than the best JavaScript engine around. And one of the reasons is that the support from there is nobody to build support that would optimize or use the Nashorn constructs in a better way and generate a better native code from that. which is not true for what we do with Graal. And one of the reasons why Graal is more approachable is that it's written in Java. So if you want to understand how your compiler works, you just get the sources, you put a breakpoint anywhere in the compiler code, and you run your Java program. And once the compiler kicks in, your breakpoint is going to be hit, the program stops, your IDE shows you exactly where you are in the compiler, and you can step through the program and find out what's happening. I'm not saying it's easy, but it's easy to get started. It's possible.
Of course. So if you're referring to compiler, you do not mean the Java C, you mean the JIT, right?
Yes, that's one of the overloaded terms that we are forbidden to mention here in the team. Don't say compilation. Nobody knows what kind of compilation is that.
Okay.
So yes, usually that means compilation of the bytecode to the final assembly.
So the Graal first, it doesn't have the actual compiler. You still use the Java C, and this is like the VM. This is called Graal VM. This is what you're referring to?
Graal compiler is the most important part of the Graal VM.
Okay.
And it's a replacement for C2 server-side compiler, or alternative to C2 server-side compiler, which is in current hotspot VM. Which kicks in whenever you find out that, or the VM finds out that some part of the program is hot. It calls into the compiler and tells the compiler to produce the assembly. So that's the place when the Graal compiler gets hooked in and does a different job than C2.
So in order to run Graal VM, you still need the actual VM, right? So the, how to call it, the JVM?
Yes, that's true.
And parts of the JVM are replaced. So they are like a hook, which is the Graal VM hook, and the JVM, our JVM calls the Graal, right?
So the hook is called JVM CI.
Okay.
It's a Java Virtual Machine interface. So it's a way how Java Virtual Machine can call into the compiler. And this hook is part of JDK 9. So actually, when you want to use the Graal compiler on JDK 9, 10, or 11, you just need the compiler jar file, which, by the way, is part of the JDK as well. It's used for ahead-of-time compilation. So you just need few switches to turn it on. First switch is use JVM CI compiler, and second is turn on Graal, or provide the Graal as an alternative, like external jar file, because it's all Java code. And that's all you need, and you will basically get the Graal VM. Plus, the Graal VM comes with support for dynamic languages, but otherwise, it's that trivial. We are using production-ready JDK, and we are just replacing the JIT compiler, because that's what we know the best.
So what I would expect that for Java itself is Graal as fast as JVM. Not faster, right?
It is faster sometimes.
So because then you already performed some optimizations comparing to the old compiler. So there is already some innovation inside the Java to Java to bytecode, not Java bytecode, Java to machine code translation, bytecode to machine code translation. This would be the right.
Yes, the Graal compiler itself has it's a different code base. The code base has not started with C2 at all. It's more like C1 compiler, which is the client-side compiler, and then we performed additional optimizations for 7 years, and now we can be better than C2.
Cool. So there's already added value here already.
Yes, certainly. Well, for example, Twitter is running on top of is running JDK with Graal compiler, because that can speed up their microservices by 10%.
A startup or what? Startup?
No, the peak performance. So
Oh,
when you
okay.
run these programs, they get less garbage. They need to do less, or the program allocates less garbage because the Graal compiler has better escape analysis, partial escape analysis, and as a result of allocating less garbage, you spend less time in the garbage collector, and you can run faster and save some energy, which in case of a global service like Twitter makes a lot of difference.
You mean power? Power and energy.
Power energy, yes.
The first time I hear someone mentioning power, so in my project, everyone talks about RAM consumption and CPU sometimes, and no one talks about power consumption. This is really crazy in enterprises. Like, the power is paid by someone else, and no one cares about that, which is strange. But
this is what we were doing in NetBeans as well, because when you produce the IDE, somebody else is going to run it, so that's his power, right?
Yeah.
But when you move to the cloud space, you need to carefully compute how much power consumptions your system is going to have, right?
Yeah.
Because you are paying the bill.
Then you have to rename NetBeans to Green Beans, Yes. If I'm running more boring Java apps, what I usually do, when Graal could help me? Which kind of apps? So I would say lots of I/O or database or CPU cycles, or what do you think would be the best case for Graal?
CPU sensitive computations, certainly.
Algorithm.
With I/O, that's the same thing.
Yeah.
Well, when talking about the Graal compiler, we are not going to help you with CPU because, with I/O, because I/O is used is the same thing. What we are going to help a lot is the allocations and actually a complicated code with lambdas. Because the hotspot C2 compiler has not been updated to modern coding constructs. But we are aware of the code that lambdas generate, and we can probably crack through the lambdas in a better way than C2 can. And this is especially true when you, for example, code in different language than Java, like Scala. With Scala, just run it on top of Graal VM with Graal compiler, and your application is 20% faster without changing a single line of code. Just run it, and that's it.
Cool. So for me, it could also affect me because now we have decision: should we implement, JPA queries with lambdas or use SQL? So if this is even faster, then we could decide for. If you have everything already loaded in memory, this could affect, architectural decisions in Java projects, actually.
Well, for me, it's a no-brainer. You just use it,
of course.
And it's faster, right? So it's not like it could affect. It's just
it is faster.
Just switch, and that's it.
Why you have to switch then?
Because you need to change the defaults. You need to change how you invoke your Java virtual machine. So
why we have those strange defaults? So at one point of time, the Graal should be the new standard, right?
That's our hope. Yes, we are working on that. I don't know if you see the Java enhancement process for Project Metropolis.
Metropolis is the name? No.
Yeah. Actually, one thing that we currently have is not that good initial speed up. So usually applications running on top of Graal, the first few thousand iterations is slower. Only then, when we reach the peak performance, we deliver on the promise of speeding everything. But that's good if you are running servers. This is what you are interested in. But we are trying to address that, and that's actually the project Metropolis. And it's going relatively well. So yes. The chances are it will become part of the JDK. If that happens, then the default, instead of C1 compiler and C2 compiler, would be Graal compiler. So,
cool.
Which would simplify the way how we maintain the code base. Because right now, there are two different compilers, C1, C2. And with Project Metropolis, we would replace both of them with Graal compiler. And that would mean single code base and moreover code base written in Java, which is easier to understand. So that's the promise that we are offering to the JDK team. We'll see whether they accept it.
That's interesting. So, but you have also different component, and this is related to LLVM, right? So you can run LLVM code on Graal. So what I understood, bitcode.
Yes, but that's more complicated. So how much time do we have for talking?
What we could do is we could have the introduction now and then have follow up.
Okay,
if you like.
Because I'm running out of my battery.
Okay. So you should be fast. So what's so there's a LLVM part. How it's related to the compiler?
Yeah, you are jumping too quickly ahead. So instead of starting with LLVM, we should start with truffle. That's the most important part. Yeah. Basically, Java has not been, or Java Virtual Machine has not been really successful in support for of dynamic languages. The strict structure of Java, when you need to know the parameters, you need to know the methods ahead of time when you do the compilation, when you emit the bytecode, makes it really hard to support languages when everything is in flux, like JavaScript. Until you run JavaScript, or one example that I give is the most complicated statement in dynamic languages. Can you imagine one?
Most complicated statement in dynamic languages. I think a caller method I can imagine.
Caller method, it's not simple, but there is even one more complicated. And that's plus. So A plus B. That's the most complicated thing you can have. Because you don't know anything about A, you don't know anything about B, and depending on the types of A and B, the plus will behave completely differently. It can.
So coercion, you mean?
Coercion? Yeah, finding the right type.
Yes.
Yeah. In some dynamic,
which is beautifully solved by JavaScript, right? This A plus, you know. The talk, there's like the what talk of languages of making fun of JavaScript, where they do exactly this, object plus a number and object plus array, and because of the dynamic typecasting, they get really funky effects.
Yes, and now imagine that you need to do this in runtime. What effect this has on a performance? So, well, there is an enormous switch statement when you need to say, okay, if A is object, if it's string, if it's number, if it's who knows what, then do something. And on the other side, you need to switch based on the value of B as well. And like this language cannot be fast.
This is what Nason is doing, right? So they're compiling all the type saved in upfront, hoping that the type is right, then compiling to bytecode, and if it's not right, they generate again, right?
That's right. That's what they do. And that's basically the solution. What you need to do is to observe what kind of runtime types are arriving into your program, and based on them, generate or speculate on the variant which is actually true for the execution of your program. So, because what has been observed is when you have a plus somewhere in middle of your source code, it usually receives numbers or it receives strings. But it's not like that sometimes it receives numbers, sometimes strings, sometimes objects. Usually the types are relatively stable. So what we have come up with is an API that simplifies writing this kind of speculative interpreters. So I use, or sometimes I do a presentation about, which is called Talk to Your Compiler. So with Java, you basically write your program and you cannot talk to the compiler. You cannot like tell him, okay, treat this field as a final field. You cannot tell, and you cannot tell, okay, maybe I made a mistake, so now like throw away the code and start from scratch. And this is exactly what Truffle offers. With Truffle, you have low-level constructs that allow you to, well, maybe high-level, depends on from which perspective you are looking at that, but allows you to use certain constructs to talk to your compiler. And for example, say, okay, this field looks like constant. So when you emit the code, treat this field as a constant. And this kind of hints that you give to the compiler can speed up your program significantly, because instead of dereference and loading a field from somewhere, it can take this field and treat it as a constant, which results in way faster assembly code. So that's truffle. And based on truffle, we have a wide set of languages built on top of this API that allow us to execute JavaScript, Ruby, R language, Python, and also all the languages that are compiled to LLVM bitcode.
But back to JavaScript. So you wrote another interpreter, or is it NAS one?
Yes, it's a new interpreter. It's a new interpreter because it does not generate the bytecode. The bytecode, the thing that has been observed when watching the Nashorn team is that they, on one side, they think about the JavaScript code, and on the other side, they should think about the assembly code. But they cannot do this mapping directly, because meanwhile they need to think about the bytecode and how they will generate the bytecode. So when another component in the system picks that up, it will generate the good assembly code. And that's an unnecessary indirection. So we don't have that one. Rather than that, we have the interpreter, which interprets the source code. And then we have the final assembly code. So we skipped the middle step. And for that, to do that, we basically had to write this part from scratch.
Okay, and you are ECMAScript 7? Yeah, 7.
We are ECMAScript 8 compliant. Well,
how you do that?
We have a whole team which tries to keep up with the latest spec.
Okay.
So I know that, for example, big integer is coming into JavaScript, into the latest specification, and there is a guy working on the implementation of that. So I don't know, maybe it's even part of the code base somehow right now.
So, that is a high priority for Oracle running on that, seems like, so that the JavaScript is efficiently it runs on Graal, right? On Truffle.
Well, it's certainly a high priority for us. What the goals are, so we have support for Node. So basically, if you want to combine Node with Java Virtual Machine, we should be the platform of a choice. So we can give you the fast executing JavaScript together with Java Virtual Machine. We can combine it with Node APIs. So basically, you can use all the you can mix these things together and use them for production. So yes, JavaScript, Node, Java is high priority for us.
Were you able to reuse something from the Avatar project, or was this also clean room implementation?
So the original approach that we had is based on the Avatar project, Avatar.js project. However, the Avatar.js project has a problem with running native modules.
Okay.
Because they actually re-implemented the interface to the virtual machine completely to use Nashorn. And we really care about compatibility. So rather than that, we at the end decided to actually hook in on the level of v8.h file. So when Node talks to the virtual machine, to JavaScript virtual machine, it uses v8.h C file for communication. And what we have is a re-implementation of this file. So basically every C code that talks through this API is going to run without any problems on top of our implementation of Node, the Graal VM Node.
This is actually very good news. So what I could do, I could take the Graal with Node.js and run my Babel on that, right?
Yes, indeed, you could.
What I found on you say you have like 45,000 certified NPMs. So it seems like some NPMs are not compatible with that. Why not? So
The usual problems is that these NPMs assume something about the V8 implementation, which violates the standard. That's the biggest problem we have, because right now we need to run in multiple modes, like being compliant with the ECMA specification and being compatible with V8. So some of these assumptions sometimes are not valid. But what we usually do is trying to talk to the upstream projects and fix the tests, not to rely on the implementation detail of V8.
But this is actually extremely good news. So really, I actually could really switch to JVM to build my JavaScript stuff.
That would be perfect. Yes, it should work. I do it myself. I basically delete Node from my local computer, and I'm using Graal VM Node instead all the time. And it seems to work quite fine.
Cool. That's perfect. But I interrupt you with the LLVM and with your. But I couldn't, couldn't wait with the Node.js. Okay, so you mentioned Node.js, and now what's the next step?
Well, we have support for those dynamic languages, but when we are so good in writing interpreters, we also decided to write an interpreter for LLVM bitcode. So every language that can be compiled with LLVM, we can interpret. And of course, so basically you can write a program in C, and instead of compiling into a binary, you can compile it into the bitcode and interpret the bitcode with Graal VM.
C is a little bit boring, but what about Swift?
Indeed.
From Apple.
I know, we did some experiments with Rust, so we know we can do Rust. Somebody would have to try Swift, but there's no problem in doing that. It should work.
Because Apple just investigates Swift on the server. They even had a guy from Netty. They on the server side. And I mean, Netty is lots of I/O, and I think Swift on JVM should, my understanding, is scale better than Swift on nothing, because there is no experience on running Swift native. So I think this could be an interesting part. And Swift is a really nice language if you compare that to plain C.
Yeah, not surprisingly. It's like 60 years older.
Yeah. Okay, that's interesting. So you have an interpreter for the bitcode, which is generated by LLVM.
Yeah, and actually, because we have so high performance interpreters, what we basically achieve is something like 10 to 20% slowdown against the optimized version of the native binary, which is not significant. That's significant, especially for the use case when what we want to achieve is interop with Java or interop with the dynamic languages. And then by having the interpreter, the compiler can actually optimize through the Ruby and Java to the C extension, which would not be possible with the native code. You know that whenever you do JNI call from Java, it's slow. And that's not the case with our interpreter, because there is no boundary between Java and our C interpreter. So we actually, with frequent switches between those languages, we actually speed up more and more and more, because we have no boundaries and we can really optimize everything.
One thing which you didn't mention, this is why I started with the method or function, is I think the problem with Java and Groovy and Scala and all the JVM languages was there is no common meta object protocol, or how to call it. So a function in Scala compiled into bytecode looks differently, or you have to know what you call, right? But it seems to me that you could actually solve that because whatever you are doing, there is a method representation in the bytecode. So at the end of the day, Java could just call Java easier with Graal. Is this the assumption? No, Graal with Truffle. Is this the right assumption? That you achieve the interoperability by having, all the languages interpreted through one runtime.
Yes, indeed. We need to have a story for example, reading a field from Ruby, from JavaScript.
Yes.
or invoking a method of Python from Ruby. So yes, the interop is strong part of that, and actually that's the part I was actually hired into Oracle Labs to help with designing APIs for this interop.
But that's as an interesting use case. You know SAS? SRSS. This is a cross compiler from SCSS to CSS. Yes. So it's like and it is written in Ruby, I guess. SAS is Ruby or less, one of this. Well, and this is always a pain. So you could actually now run SAS on Graal and run the Node.js app also as Graal, and both are interpreted by Graal, and they can very efficiently communicate with each other, for instance.
Yes, they
could. Thinking about the use cases.
I didn't know that SAS is written in Ruby. So that's
SAS or less. So one is in JavaScript and the other one is in Ruby. Either SAS or less. So one of them is Ruby, and which causes some pain in the community, what I understood. And
in such case, we could solve it, because people could all use Graal VM and that would work smoothly. We don't care about the languages, all work fine.
Another cool thing not mentioned that, I think we covered a little bit Graal and a little bit Truffle, but there's also cool stuff with cool name called Substrate VM.
Yes, it is. That's a basically way how to do ahead of time compilation of Java.
And then you get one binary, one drop-in, like in Go?
Yes, exactly.
That is even there are lots of.
So what you mentioned is that nobody cares about the power consumption. Everybody talks only about the memory consumption when it comes to cloud services.
Yes.
And memory consumption of Java is huge, because it needs to keep a lot of meta information around when executing the program. And ahead of time compilation done with Substrate VM can solve that all, because you get a binary. And then you don't need any meta information whatsoever. Everything is in the binary, and you run it like Go. You run it like Go, and it runs. It starts fast, because what we actually do is when generating the image, we pre-initialize the program in the real Java virtual machine. So all the static initializers can be executed in the host in the Java virtual machine. And only then we take snapshot of the memory, and from that we generate the native image. So you can actually put your application into pre-initialized state, and then when you start it in 1 millisecond, you are exactly in the state where you want to be, and you can start your computation, which is ideal for function as a service, I'd say.
Yes, this is interesting stuff. So. Remaining thing for today is, so there are different versions how to download Graal VM and the SDK. One is OTN and the other one is open source. So I tried to download something for the Mac. Nothing is available. I will have to use the OTN stuff. So
yes,
you have
please do so. And generally using the OTN stuff is better. You will get better results.
Yeah, but I have to provide username and password, and this is unusual for the OTN stuff. Usually you have to accept license, or you have to have account. A question to me, can I build it from sources? Is it painful? Is it possible? Or I should just download the OTN stuff?
The open source version shall be buildable from the sources, but I have not tried myself. I don't know how painful is that. Sometimes the dependencies are sort of wild. I remember when I wanted to build a fast R language, it requires Fortran and GCC and stuff like that. So sometimes it's hard to get the configuration. But I hope that now when we are open source, we will actually be able to get into the Linux distribution. So then there should be an open source package one day for Linuxes. And the build should be basically stabilized and standardized. But better to download the OTN version, I say.
And you know, what is the idea of OTN is just, I get the enterprise edition, but the open source edition, why not from GitHub? Is there still some issues or licensing issues, or what's the problem with that?
Do you mean, so the open source edition is available from GitHub, right?
But only Linux, and the OTN, I get Mac, Linux, and Windows, so this is like...
Honestly, the team was pretty busy during last 14 days.
Okay.
And I'd say it's great success that we have at least the Linux version.
No, okay, I fully understand it.
So
my first
there
impression
should be
was
no problem in producing the Mac version as well. And there is some demand for the Windows version. So yeah, I assume we will be able to provide a Windows version as well.
Yeah, just for development. I usually running Docker and Linux so it should be fine with Linux. And this is absolutely fine to have the OTN version, like hardened and more tested with more security and support. But I think in longer term, everything should be at least binary for Mac and binary on Windows should be available also for GitHub. It's more convenient.
Yes, that's the goal, definitely.
So this is your homework until our next session, right?
That's our homework that we will finish by end of summer, I assume. Maybe sooner, maybe beginning, who knows. But beginning of summer plus minus 6 months.
Perfect. Yeah, this is always good estimation. Really thank you for the interview. And where people can find you? So do you have Twitter and, Graal, VM, resources, whatever you like to point the listeners to?
I think graalvm.org is a natural good start for finding all the information about this Oracle Labs project.
And your Twitter account is?
Again, GraalVM. That's a Twitter account when people can follow our developments. And
your development, you are Jaroslav Tulach, where people can find you?
My Twitter handle is Jaroslav Tulach, and my personal website is apidesign.org. So
API design, which should be one of the topics, if you like, in the forthcoming episodes.
That sounds like a good idea, and we still have some topics to cover with Substrate VM, and maybe when you play with Graal VM, you may have more questions, more complaints, and I'll be happy to discuss them. Yeah.
So I will try to complain as much as I can. So thank you.
You're more than welcome. Thanks a lot.
And here the next time.
Bye.